inverses of exponential functions. So here comes our first problem here. It says, it's kind of cool, describe the function as exponential, logarithmic, or neither. And how do you know it's that kind of function? Then 5 points for its inverse. So we'll just kind of look at these x values and these y values, and we'll figure out if they're going linearly, going by a constant amount, or exponentially, going by a constant factor. So this right here, you can see these powers of, looks like it's being taken times, no, it's being multiplied times 3. Okay, now you could find this out at any time. Here, I'm going to grab my calculator so you can see. I can do it with fractions in my head pretty easy. And the way I'm doing that is I'm just looking at, I'm saying, hey, what do I take 1/27th times? Times x to give me 1/9. And I'd say, hey, if this was a 3 right here, it'd give me 3/27. It just simplifies one of the 3's out, which gives me 1/27 divided by 3 is 9. So I can just kind of tell what it's doing here. Not sure why I'm writing in pencil right now. I'll just switch over to a pen here, hopefully. But you could also just say, hey, what's 1/9? So I've gone to my calculator here, 1/9 divided by. Now I have to be careful there. I want to make sure I do it the way the math is intended to go. I want to take 1/9 and divide it by 1/27. So you do that. You'd also throw it on your paper and say 1/9 divided by 1/27 is the same as 1/9 times 27, which is 27/9, which is 3. Now, that's what 1/27 times 3 gives you 1/9. We also have to check it though. Obviously, just taking it times 3 give me the 1/3, and taking it times 3 give me 1, and it does. 1/9 times 1/3, they give me 3/9, which is 1/3, and 1/3 times 3, it gives me 1. So we can clearly see the x's are growing with a common factor, or by a common factor. Okay, let's see what the y values here are doing. So the y values here is going +1, +1, +1, so they're just going up 1. So this is logarithmic. Because the x values have a common ratio. The x values have a common difference. Something to that effect. Now when we do the inverse, all that does is take the y values here. So here's our y values. They become the x values, and then they map back to the original x's. So -2 is going to map back to 1/9. -1 will map back to 1/3, and 0 will map back to 1. Okay, it's just how they pair, how they map to each other. I'll jump to problem number 2 here. So again, I can see, I just start looking and I can tell these are going up by 1, up by 1. So now our x's are growing with a common difference. And let's see here, this looks like times 4, and 1/4 times 4 is 1. So this one is exponential. So in this case, our y values are going by 4, and again, we just flip-flop all these x and y values. So I'll write down all my x's here, all my new x's, and then 1/64 will map back to -1/3, you get the idea. So there we go. functions and their inverses. Let's see, directions determine if f and x and g of x are inverses. So to prove two things are inverses, you have to throw that f of x, the f of g of x is equal to the g of f of x, and they both have to be equal to x. So generally what we do here is just prove this equals x, then prove this equals x, and then they are inverses. So let's do that. Let's find the f of g of x. So I go to the f of. Now, g of x, we're going to change out here. G of x is 3 to the 1/10 times x up here. You could write that as x over 10 if we wanted to. And now we have to substitute that into function f. So here's function f. Right here, we got to take 10 times the log of 3, log base 3 of whatever you're plugging in. Well, we're plugging in this 3 to the 1/10 x. And so our function will begin to look like this. 10 times log base 3 of the quantity 3 to the m. I'll write that as x over 10. Like that, just for convenience sake. Alright, so let's see if we can figure out what this is equal to. Using laws of logarithms, this exponent in here, this can come out in front of the logarithms. Now we got x over 10 out there, but we still have the log base 3 of 3. But log base 3 of 3 is just equal to a 1, so this is 10 times x over 10. 10's cancel, giving us x. So f of g of x is equal to x. Check. But now we got to prove the other half. Okay, so now we're going to go, hey, does the g of f of x also give us x? That would be the g of, now f of x is 10 log base 3 of x. So we're going to substitute that into function g. So here's function g, 3 to the 1/10 times 10 log 3x. Notice I put this in the numerator right there, and that's because it's in the numerator. Okay, this x is right there. All right, so let's go ahead and multiply this little section out. So this is just going to divide this red factor by 10, the 10 in the denominator. And so we're going to get 3 to the log base, boy, that is really wide there. Here we go, equals 3 to the log base 3 of x, and this is just equal to x. 3 and log base 3 are inverses, or 3 to the power and log base 3 are inverses of each other right here, and so those two knock each other out, and you just get x. Another way to look at this, and I can show you right here on the calculator so you can see it, which is 3 raised to the, and I use my math button here, so I can get log base 3 of. And you can put anything in there you want to, like 50, for example, and you'll see it just gives you 50. Okay, and that's going back to logarithms and their inverses. So if we just pause for just a moment here, and I'll show you real quick what I mean by that, so you can kind of maybe get a better grasp on this. So let's say I've got y equals 3 to the x. And then I wanted to find, let's start that again. Say I've got y equals 3 to the x like this. And I want to find its inverse, y equals 3 to the y. I change the logarithmic form and I go y is equal to log base 3 of x. So f of x is this blue one. And its inverse is the one we just found. Oops, there we go. And so if I find the f of f inverse, for example, it looks like this, 3 to the log base 3 of x. Those two are inverse functions, and so they just give you x by definition of what inverses always have to do. Okay, so I've got inverse functions in this problem right here. I got a 3 to the power, and in the exponent, what have I substituted in? The inverse of it for my exponent, log base 3 of x. So log base 3 of x does something, then 3 to the power undoes that. and you end up with x again. So these two are inverses, and we have shown they are by showing that the f of g of x equals the g of f of x, and they both equal x. All right, so let's jump to number 4 here. I'll try to stay on target with this one, or on task. Let's get rid of that. And so here's our next problem. F of x equals 7 to the 5x. G of x equals 0.2 log base 7 of x. And again, we're just going to see if we can prove they are inverses. So I go to the f of g of x is 0.2 times log base 7 of x, which is 7 raised to the 5 times 0.2 log base 7 of x. I can multiply the 5 times the 0.2, and I get 7 to the log. Yeah, that just 5 times 0.2. 5 times 2 is 10. Move your decimal 1. You get 1. So this is just log base 7 of x. And there we go. We got inverses again. 7 to what power? Log base 7 of x. They cancel each other out, and I just get x. Then we'll rework it with g of f of x. So putting f of x into g. There we go. And I get 0.2 times the log base 7 of 7 to the 5x. The 5x gets to come out front and be multiplied by the 0.2. Log base 7 of 7 is just 1, so this is also 1x, or just x. Check, check. They are inverses. Find the inverse of the given function. So let's just do our flip-flop first. Change to y notation. Flip-flop where x is with where y is. Now we're going to change to logarithmic form. So I'll go log with a base of 2 of x gives me 1/8 times y. And then I'll multiply both sides times 8 to get rid of that 1/8. And I'll get y equals 8 log base 2 of x. And that would be h inverse. So we'd write h inverse of x is equal to 8 log base 2 of x. Now, just as a quick reminder here, I'm going to throw this thing on Desmos so you can see that these two are indeed inverses of each other. Remember, you could check these pretty quick. Now, you don't have to use function notation. Okay, so there we go to the 1/8 x. So let's see how this does this. 1/8. Did that just fine. Like I had the x off to the top, or off to the side rather, or up here in the numerator. I'm going to put it up top because that's where we really want to show it. X over 8. And you can see you get this exponential growth function. The base is 2, so that's going to grow. And then here's the inverse. Now, remember, the inverse is going to be symmetric about, or reflected about the line y equals x. So I'm going to draw that line y equals x in there. X like that. There we go. I'll make it dotted. Dot, 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 like that. And so my inverse should be reflected over that line. So let's take a look at this logarithm. Here we go. Y equals 8 log, a little tougher on these things, log like that. And then I can hit a underscore button, which looks like, if I can find the underscore button, see the underscore button anywhere, it won't let me do log base 2 without going into my functions. There's a log, and it let me put a base 2 in there of x. There we go. So yeah, those two are inverses of each other, and you can see it right there. They have that nice reflection about that dashed line. Let's make it dashed instead of that. There we go. And that's what inverses should look like. And then finally number 6 here. Again, I'm going to do my switch and change here real quick. So I'll change this to y, but then I switch it to x because I'm going to exchange my x's and y's, just like that. Now to get my y alone, I first have to get rid of this 4 here. So I divide by 4, giving me x over 4. Now the log's alone, and now I can change it into exponential notation. So my argument is going to be equal to my base. Now my base here is base 10, and my exponent is x over 4. So there's what y is equal to, and that's my m inverse in this case. So I'd say m inverse of x is 10 to the x over 4, or 10 to the 1/4 times x, like that. They've kind of had a penchant for doing that. I'm going to go ahead and put these in here too, so you can see those two are also inverses. So I've just adjusted my red one here. There we go. And I'll change my logarithm to 4, we'll make the base 10, so I think I just have to delete that little 2 right there. There we go. And now we can see the red and the green one are reflections about that line, y equals x. Alrighty, that should do us for that sheet, I think.